All right, I'm going to do a couple of examples from the lesson 8.3 assignment, 11.3 assignment. Actually, both sections, the front and the back, have a little bit different directions, but they're very similar in how you do them. The first one is going to use the altitude, the theorem that has to do with the altitude, because we're trying to find the altitude. So anytime the altitude is given or we want to find the altitude, we're going to use the proportion that has to do with the altitude. So that one says, and I like to put it in words, the altitude is the geometric mean of the two segments of the hypotenuse. So segment 1 of the hypotenuse and segment 2 of the hypotenuse. So we need to find the altitude, so now we just plug in. So I make my proportion again, and I'm going to plug in the values. So one leg of the hypotenuse is 25. The altitude is x, that goes here and here. And the other segment of the hypotenuse is 11. So we have a proportion. The way that we solve a proportion is cross multiply. So we have x times x is x squared. 25 times 11 is 275. And then we take the square root of both sides. Take the square root of both sides. And the directions say leave your answer in simplest radical form. You can do that, but you can also just do the decimal form. So first I'll do simplest radical form, which probably would have been easier to just leave this as this 275 as 25 times 11, because the square root of 25 is 5 root 11. So that is the simplest radical form. But if you are not familiar with how to do that, you simply can take the square root of 275, so square root of 275, and you get 16.6. So either answer is fine. You don't need to put it in simplest radical form. If you know how to, I would appreciate you doing that for the practice and just reminding yourself how to do that. The next one, find the missing length. You might require 2 steps. I don't think that it does, but we'll take a look. Leave your answer in simplest radical form, and again, you can leave that in decimal form. All right, well, this one does not have to do with the length of the altitude, so we're not going to use this one right here. We're going to use the other proportion, and that proportion says a leg is the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to the leg, and that's the leg that we're working with. So, do we have all of these things? Well, what you do is you just really start off filling things in, seeing if you have it. So do we have the length of the hypotenuse? Well, we don't, but that's what we want to find, so that goes there. Do we have the length of a leg? Yes, we have 40. So 40 goes here and here. And then the last thing, the segment of the hypotenuse adjacent to the leg. Well, there's 2 parts of the hypotenuse. There's this green part, and then there's this red part. Do we have the one adjacent to the leg that we are talking about? And we do. It's the 25. So sometimes you might have to find a length, but this one, it was given to us. And so now we have a proportion that we can cross multiply and solve. 40 times 40 is 1,600. Divide both sides by 25, and we get x is equal to, so 1,600 divided by 25 is 64. So x has to be 64. And there's a few examples for you to follow.